Okay, so here scanf %d ampersand. Okay, so there are two. One is %d, one more, row 1, first matrix, column 1. So we have to read the two values. So let me control insert, shift insert, control KK. Now, if I want to do the order of matrix B, so here we have 2 and column. So we are having the row 2 and column 2. Now, if you want to join, what is the condition? Row 1 should equal to row 2. Okay, and column 1 is equal to, row 1 is equal to, yes, row 2, column 1 is equal to column 2. That means the two matrix order should be same. If it is not equal to this, okay, if it is not equal to this, okay, then you cannot perform any operation. Printf addition cannot be done. So you cannot do this. But if it is there, other than that, you can perform. Other than that, you can perform. Now, first question is how to read this value. Say printf read the first matrix A. So A of I, J I wanted to read it. So that is nothing but rows and columns. So this is what I have to do. How many rows and columns I have to do that? That is nothing but row 1 into column 1. That is 4. If it is a 2 cross 2, 4 elements should be entered. So that is nothing but I can write here. Enter the first matrix elements. Here I can write %. Slowly try to understand this. Don't worry. Initially it looks very tough, but it is not so tough. Okay. So %d means row into column. Enter the first, read the first matrix, or enter the first matrix. Okay. So 8 elements, 4 elements we are telling. Similarly, I wanted to do scanf %d. Okay. Ampersand F I.
Okay.
F ij. Okay. Fj. Okay. So here I have to read this.
No.
Amit,
Copy invite link, invite participant chat,
Amit,
and request permission to record on this computer. Request host to start.
just give me 2 minutes. So now I also there, J also there. Now if you see this, for I need I and J value for a movement purpose. So let me write I comma J. Now if you look at this, I is equal to 0. I less than how many? Row 1. Okay. How many rows? 2 cross 2. Okay. I plus plus. Once you execute, you will understand this. So then similarly for J is equal to 0. J less than column 1. J plus plus. So we have done this. So we are able to read the value. Similarly, I want to read the another matrix. shift insert, control KK, enter the second matrix. Second matrix. So here number of rows and columns will be almost same only because we already checked that condition. But still for our reference, we are doing this. Read to column. So we are able to do this. Similarly, we are making B. So B of ij. So we have row 1, column 1, row 2, column 1. So column 2. So we are able to do both. Now, once again, if we do this, then I am going to do the addition operation on this. How do you do the addition operations? So let us do this. Okay. Now I have read the values. Let me print f perform addition operation. So now what I have to do is I will copy this for loop. One is for row, one is for column. So 0, 0, 0, 1, 0, 2, something like that. Then I want to do C of ij. C of ij is equal to A of ij plus B of ij. So this is how we have to write it. Once it is done, just I have to display the addition. Now I will do that for I is equal to 0, I less than anyone. Now row 1 is equal to row 2. So you can take row 1 is equal to row 2. Both are same. So row 1 I can take I plus plus. Okay. Similarly, so here like I have taken column 2, I can take row 1, column 1 also. So because both orders are same. Now let me go here once again for j is equal to 0, j less than column 1, j plus plus. Now if I display, let me display in the matrix format. So print for every row, printf, I will be going for new line, next line. Okay. So for every column, printf, tab, I will print %d. Okay. Next is, okay, CF, CF, J. Semicolon. Close the bracket, semicolon. So now I will add here. So then we'll make a get ch. Now if you see this, okay, we started with reading of what is matrix. Matrix is a two-dimensional rows and columns. Okay. So we here then how to read that value we have understood. First we have to read the order. Then if both row 1 is not equal to row 2, that means the row of the first matrix cannot equal to the row, or column 1 is not equal to column 2, then addition cannot be done. Enter the first matrix. So okay, able to hear me? Okay.
Excuse me, sir. Actually, we are not able to see what you are sharing.
Okay. So let me go back. So now let me go once again. So I'm sharing the screen. So here, just we are working with, so row 1, column 1, 3, 3, BC 3, 3, row 1, row 2, column 1, column 2. See here if you see this. So here row 1 ampersand is missing. So I will be adding this. So there should not be any space. Please remember. Otherwise it will be a problem. Just check any gap is there. So there is no gap. Let me run. Then after that, once again, I will explain. So there is a semicolon missing. Okay. Okay. So here scanf statement is missing. Okay. For I is equal to 0. J. Here 2 brackets. So here semicolon. So let me order of a matrix A 2 cross 2. B, both should be same. Enter the first element 1, 2, 3, 4. Second matrix 1, 2, 3, 4. Now you can see the combination of the two. 1 plus 1, 2. 2 plus 2 is equal to 4. 3 plus 3 is 6. And 4 plus 4 is 8. So you are able to see the order of the matrix. So we are able to see the order of the matrix. And addition of 2 matrix, we are able to do that. In display, let me print the heading. Addition of 2 matrix is this. Now, if you make it this, you can able to execute. Similarly, like here also, if you want to print, you can print the A, B, C, anything. But this is how the simply. So just we started with, okay. Started with simple array concept. We are able to do so almost the 45, 46 lines of code. So now let me execute once. So here, so it is not saved. Control F9. Get ch. For I 0, this is 1. So end for this addition, subtraction. So else part is not closed. So I will close this. This is for else. This is for display. So you should always note it down. 2 plus 2, 2 plus 2, 1, 1, 1, 1. Second matrix, 4 element I have given. So addition of 2 matrix is 3 cross, so that, sorry, 2 cross 2 in that 3, 3, 3, we are able to display. So this is how we can do the simple addition. Now, similarly, if I want to perform subtraction, okay. So if I want to perform subtraction, control insert. So later I will convert this into a function. Okay. Shift insert. Okay. So here, instead of addition, subtraction. So when you are doing a subtraction, so then this should be a minus. Then minus. Then let us display. This is addition. Let us display. Now let me run this. Okay. Else. So 2 cross 2. 2 cross 2. 1, 2, 3, 4. 1, 2, 3, 4. You can able to see. So addition of matrix is same number. So 2, 4, 6, 8. 2 minus 2 is 0. 4 minus 4 is 0. 3 minus 3 is 0. So because of that, you can see that is not addition. That is a subtraction. Just me change the display message. This is I will do as a not addition. It is a copy paste issue. This is subtraction. Now let me run once again. Control F9. 1, 2, 3, 4, 2, 3, 4, some random number. So this is I am getting addition of 2 matrix and subtraction of 2 matrix. So this is how you can perform. So let me write the same thing. If I want to do multiplication, there is some rules are changed. There is a row 1, column 1 is equal to column 1 is equal to row 2. So 2 cross 3, 3 cross 2, something like that. Okay. The first matrix, first matrix column should be equivalent to the row of the second matrix. Then only we can multiply. That's all. Otherwise, we can do like this. So that is the multiplication of the program. Now, let us try to, because it is so lengthy, definitely it is very difficult. Similarly, if I want to transpose of a matrix, transpose means row can be changed to a column, column can be changed to a rows. If I want to do that, okay. So let me do that. So let me take this. Let me copy everything. So this is transpose of a matrix. Row will be changed to the column. Column will be transpose of a matrix. So now, if I want to do the transpose of this matrix, it is nothing but, for example, if I want to Cij only, I wanted to change, okay, C of ij is equal to Ji. Okay, so I have changed so this is called transpose of a matrix. Now let me run this. So 3 cross 3, 3 cross 3, 9 elements have to enter. 1, 2, 3, 4, 5, 6, 7. Similarly, I can enter second matrix. So why it is not coming? So 0. So usually last subtraction is something coming wrongly. So let me do this. C of ij is equal to C of ji. Column has changed to row, row changed to column. Okay, transpose of a matrix, which is C. Let me row this. Control F9. 2 plus 2, 2 plus 2, 1, 2, 3, 4, 4, 3, 2, 1. So like this. So if you look at this, okay, it looks very same. Okay, 3 minus 1, 3 minus 1 came here. Minus 1 should come here. So somewhere some mistake is happened. So usually not control F9. This which matrix, what is the result matrix here? Let me print. This is the last matrix. This is the last value, C of ij. So row I is equal to j. J value, row I am introducing to column. Column I am introducing to the row. So let me go here. 2 plus 2, 2 plus 2, 4, 3, 2, 1, 8, 7, 2, 1. So here, like usually, there is some mistake in transpose. I see that, but this is how we can do the transpose of a given matrix. Transpose means row 1 should be changed to a column. Column should be changed to a row 1, and somehow we have some mistake is there. What is the title? Okay. So let it be. So I will see it later. But at this moment, so we have understood what addition of two matrix, subtraction of two matrix. These are too straightforward. This will give an example for you people how to transpose from like a one form to the another form. Like similarly, if I want to perform, let me take one more program. Before that, let me explain. Okay, so let me go here. So if what I have done is, if there is a matrix called A, okay, 1, 2, 3, assume that 2, 3, 2, 1. Okay, similarly, I have a matrix called B. Okay, so here I may be having 2, 3, 4, something like this, 3, 4, 5, something like this. If you have this, then how do you perform sum and subtraction? We have seen. Subtraction is like this. So 1 minus 2 minus addition means 1 plus 2, 3, 3 to 5, 3 plus 4, 7. Similarly, 3 plus 3, 6. Okay, 4 plus 2, 6. And similarly, 5 plus 1, 6. We are able to do this type of operation. Similarly, minus means, okay, we can subtract this. Actually, transpose means, so what I have expected is 1, 2, 3 should be changed to 1, 2. Similarly, here, first matrix A should be 3, 2, 1. Row should be column should be row. That is a transpose of a given matrix. Like this, we can do many operations. So that is not a difficult task actually. So we can do that actually. Similarly, if I want to perform multiplication means, usually multiplication means usually row 1, if it is a row 1 column and column 1 for a first matrix, second matrix row 2 and column 2. So we will use the P, okay. Then A star B matrix will be equal to, so usually row column 1 should be equal to row 2. Then only we can perform matrix, perform multiplication. This is mathematical explanation. That only symbolically how to do. So we can see that if you want. So here row 1, so column 1. So we can read the matrix like you can row 1 column 2, 3, and if you want 2 cross 2. Okay. Similarly, if second matrix should be column 1. What is that? Second row is number of rows is 2. Column is equal to 2. Then you cannot say that 3 second matrix B should not be having 3 cross 2. So it should be, this is the column 1, this is the row 2, both should be equal. So this is what row 2. But column 2 can be equal. Column 2 can be empty. So column 2 can be 3 also. But what we have to check, column 1 is equal to row 2 for doing the multiplication. This is a mathematical the representation. So likewise, so when you are performing with a 2-dimensional matrix, so I also can write, okay, 1, 2, 3. Usually, if you look at this, 2, 3, 5, look at this, 6, 7, 8. Assume that this is a matrix. Now, usually this is represented in equally. If you look at this, so 0, 0, 0, 1, 0, 2, This is 1, 0, 1, 1, 1, 2. Similarly, this is the second row, 0 column. Second row, first column. Second row, second column. So this is how rows and columns are established. Rows and columns are established. So that means in an array, okay, in an array, 0, 0 row is 1, 2, 3, 2, 3, 5, 6, 7, 8. So this is how in sequence it will be placed in the memory. But we are visualizing 0, 0 means 1, 0, 1 means 2, 0, 2 means 3, 1, 0 means 2, 1, 1 means this, and 1, 2 means 5, 2, 0 means this, 2, 1 is this, 2, 8 is this. So this is how memory representation but this structure below 1, this is the matrix representation, means visual representation. So we are looking into this 0, 0 column means this. So 0, 0, 1, 1, 2, 2. This is called principal diagonal. This is called as a principal diagonal. People may ask you to find the sum of principal diagonal. So they can ask. Then what is expected is 1 plus 3, 4, 4 plus 8, what is that? 12. So it should give 12 for this. Where when you say principal diagram, if you observe, what is the condition? Ith row is equal to, so this is I, okay, ij, okay. So if you see the row is equal to column, so that is nothing but j, 0, 0, okay. Here also 1, 1, both are equal. So this is nothing but we can perform the sum is equal to sum plus a of I j. So if you do this condition, then you as good as you are making the sum of principal diagonal. Principal diagonal means 0, 0, 1, 1, 2. So this is what you are doing. Similarly, if you want to perform, okay, above the diagonal, find the sum of principal above the principal diagonal. So if you want to do that, then you observe 0, 1, 0, 2, 1, 2. Here always first element 0 is lesser than the second element. That means I is always lesser than j. Here I is lesser than j. Here also I is lesser than j. So that is nothing but above element is always condition will be if I greater than j, sum is equal to sum plus f ij. So then you can perform this. Similarly, if you want to see this, so why I'm explaining this, you have to start observing the data and representation and question. Based on that, you have to map, build the logic. Similarly, find the sum of the below the principal diagonal. So if you talk about this, if I less than j, if you observe here, so for I greater than j, here I less than j, this is the I less than j, this is I greater than. See here below this one, I is always greater than the second column. So I is greater than j, 1 is greater than 0, 2 is greater than 0, 2 is greater than 0. So these three elements sum, we can see that. So this is nothing but if you do that, it is below this. Okay. So likewise, we can play around with two-dimensional matrix. Let us do this program for quick understanding so that you can have some more understanding. Let me go back. So, please don't use any marker. Okay, so here open. So matrix sum dot. Now, if you see this, now we are talking about how to perform sum of principal above the principal, below the principal diagram matrix. Now, if you want to do that, cache include studio.h, cache include conio.h, void main. So now, if you look at this, I wanted to first do the declaration. So first I need one matrix, maybe 4 plus 4, something like that. I comma j, that is required. Row, column, that is required. Sum. So this is required. Now clear screen. So we have done this. Now printf, enter the order of the matrix. So how many rows and how many columns? That is nothing but order. So here, when you do this, scanf, %d, ampersand. So there are row and column. So row, ampersand, column. So at any cost, don't give like space like this. So just understand this is, there is no space should be there in the scanf. So once this is done, now I have to read the value, read the new line, read the matrix. So now for int, sorry, I is equal to 0, I less than row, I plus plus, for j is equal to 0, j less than column, j plus plus. So usually it is a habit of writing like this. So we have to write like this, but one row can take a one statement without doing that also. Scanf, %d, ampersand, fi, j. So like this we have to write it. But normally once you get practice, we will be knowing that one for loop will take another for loop. This for loop will take one line is there. We do not require anything, just we can use it. But as a beginner, probably if you have a confusion, better to use for bracket for flower bracket for everything. So this is for this for inner for, this is for outside for. So once this is done, now I wanted to compute sum of principal diagonal. Before that, I wanted to print the value. So let me print this. Whatever I have read, for my understanding. So we will do this. So display the matrix. Display the matrix. So row column. So here matrix format only will use. Printf %new line. So every row, I'm going printing the new line. Cursor should go to the next line. So here printf instead of scanf, printf. So %t. So remove this ampersand. So this is will be this one. Now, once this is done, let me perform sum of principal diagonal. As I explained, for I is equal to 0, I less than row, I plus plus. Similarly, for if you are a beginner, you can use this for j is equal to 0, j less than column, j plus plus. Okay, so we have done this. If I double is equal to j, row is equal to column, sum is equal to sum plus a of I j. So when both are same, this is if condition, this is for this is for another for. So we are started with for this for loop 0, 0, 0, 1, 0, 2, 0, 3. Similarly 0, 1, 0, 1 to 0, 2. So like this we can do this. This is sum of principal diagonal. Then printf the principal diagonal sum is, what is that? Sum. So once this is done, let me add get ch and close this. And here also everything is there. So now let us run this. So unexpected, okay. Control F9, order 3 cross 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me correct this display format. So here I will make this as a new line. Control F9, 3 cross 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we have got it, so 9. So if you look at this, one principal diagram is 159. The sum of that is 9 plus 1, 10, 10 plus 5, 15. So this is how we can print the sum of the principal diagonal in a matrix. Because when I is equal to this one. So sum of the principal diagonal, okay, of a matrix. Similarly, if I want to print above that sum, so just we are talking here how flexibly you can write the program. Control insert, shift insert, control K. If it is I greater than J, sum of, okay, below principal diagram where I is more. So then not is equal to, because we are not considering principal diagram. So below the principal diagonal, that sum is. Similarly, let me take above that. Let me copy paste. Shift insert. Control KK. So here I am doing reverse of this. And here above the principal diagram. Now let me execute. So here, if I want to create 3 cross 3 or 2 cross 2, something like that. So let me create 3 cross 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you look at that, sum of the principal is 15. Here, like below, like 12, something it is there is equal to, we have taken, I think. So it is adding sum. Okay, so I have to clear this. It is taking the previous value. I will initialize to 0. Here also same variable I have used. So it is combining previous value. So reinitializing. So 3 cross 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see that. So now if you look at this, you can see that. So 2, 3, 6, that is 9, 10, 11 is there above the principal diagonal. The principal diagonal 1, 5, 9, that is 15. 4, 7, 8, that is nothing but 19. So below the principal diagonal. In this way, you can perform operation on the two-dimensional matrix, and this give an indication that, okay, so we can create n number of array in the matrix to represent two-dimensional data. So to understand that, this is an example to showcase how to use an array. Okay. And if you want to, instead of writing this, if you want to change to a function, so what you have to do? So you have to scanf, read it. And if you want to display, you can write all these things into a separate function. So control insert, then you have to move to the outside of this, outside main. Then you have to copy paste here. So here, printf. So now outside this display, now let me use this method. So let me write function void display. So I can pass a row, int column, and matrix A. So if you do this, then you have to write a function for this. So repeatedly, now this method, not only learning two-dimensional, how to use the function also we'll see this. So just for readability purpose, I have to. So what is this doing? Display of matrix. Now, so wherever I am calling for display, I can use this. And here I can call that function. So let me call that function display. So what is you have to pass? Row, column, and A. So you have to call this array, how to call. So I'm removing the display now. Similarly, control insert. So I want to reuse this display every time. So this is done. So that's it. So now I wanted to declare this control insert because it is a C program. We have to declare somewhere. Okay. Control KK and control F9. What is this? Yeah, 5J. So we have not done. Okay. So this is of integer type. So here also integer. So we can see that 4,4. So never used. So I will correct everything. Let's check. So declaration error 3 cross 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got the same output as earlier. There was no change, but only one change we have made it is display. We have made it as a reusable function. Similarly, if you want to read, so I can move outside and then I have to read the value. Okay. So, and if you want to computation, if you want to move, I can do that. So let me move the computation. Let me write sum of the principal diagonal. So there is one function I wanted to write sum of the principal diagonal. So let me take this control insert. So let me go here, shift insert, control K. So now I have to compute void return. I will do that if I want to that int principal diagonal circle. So something like this I am giving it. This one. Otherwise, to keep it short, principal diagonal sum. Okay. So row, int row, int column, int. So you have some numbers. That's it. Maximum number I have given. Now, once this is done, performing a sum. So now sum initialized to 0. So now return sum. Return sum. Now I have to declare this. How do we do in the function? So let me do this. Move this to above here. Control KK. Add the semicolon. Now, so computation, I am removing this. So I am principal calling that function name. Function name is P underscore D is equal to sum. So instead of this, P underscore D is equal to sum, I am passing row, column, A. So this is how I am passing. And then let me save this. Control F9. So one more bracket. Control F9. So here sum is equal to 0. Int sum is equal to 0. I comma G. So it is telling that I don't know that variable. Okay, so it's in the function 3 cross 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see that why I got 0. Let me see this. Sum is equal to 0. Okay, row, column, Fij, row into column, return sum. So what I have called here. So compute principal sum below the matrix. So I have done wrongly. So instead of this, I should have done there. This is not the one. This is not the right place. Control insert, delete. Let it be sum. Actually, I have to do here. Because, so here, control KK, sum. So now let me try. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see that the principal diagram, 15 it should come. I have to see that. What is the value? So principal diagonal outside display. So principal diagonal is done. A is passed. And so what is the condition I have done? Display. So here wrongly I have done copy paste. Okay. Control F. So 3 cross 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are able to see the principal diagonal is 15. Okay. So this is how I can slowly, once you write a lengthy program, usually better to write a function, transfer to the function. If you want to transfer an array, basically what you have to do is, so you have to pass the array name. And receiving end, so you have to write the receiving, the whatever the maximum size you have to mention, So below, within that, how are we declared? We have declared and we are able to use it. I think this give an idea how to use an array, how to use a function, how to use a two-dimensional array, and we can perform. There are many things, many examples we can do it. At this moment, we will hold it. From tomorrow, we'll take the new concept and we'll try to understand what is macros. This is hash include. We will discuss about this, what it is, how it works and all, and try to understand better C program. So any question before conclude? Yeah, any questions from anyone? Okay, then I think if no questions, we will conclude. Any questions before concluding? So I didn't get, okay. So no questions. So I will be stopping the recording. Okay. So thank you very much for joining. Thanks a lot. See you tomorrow.